Good morning to all my dear students. Myself Susri Priyadarshini, lecturer in Mechanical Engineering at Bose, Cuttack. Today we will study about one of the most important chapter of your 4th semester Mechanical Engineering, that Thermal Engineering 2, that is air compressor. Okay. Today we will discuss about this chapter, that is air compressor. Initially I will tell about the contents, what we will study in this chapter. Then gradually I will explain all the features, all the what is the application of compressed air, what is the function of air compressor, and what are the different types of compressor. We will discuss about everything. So, before starting, I just want to ask you, ask all of you one question, that have you gone through the air compression in your air compressor in your day to day life, or simple compressor in your day to day life? Yeah, the answer must be yes. You all have gone through the compressor in your day to day life. We all are acquainted with this, and we have seen in our daily life. Have you gone to garage for the filling the air in your vehicles? Yes, you all might have gone to the garage. At that place you might have seen the air compressor. Okay. Maybe some students are not aware about this, but you must know that is the air compressor, and why they are using that air compressor at that place. And similarly, air compressor has various application in our society or in our day to day life, and you will definitely go through the air compressor in your life. So, before that we need to understand what are the concept. Though you are the mechanical engineer, you all should know the features, the parts, the applications, the functions, everything, and advantages, and what is the need of it, why we will buy it, why we will use it, and what are the different uses. Okay. So, let us start our class. This is your first class. In the first class I will cover some portions, and gradually I will complete your syllabus. So, coming to our content page, in this content page I will cover these portions, that is in your syllabus. You have gone through your syllabus. So, first is function of air compressor and uses of compressed air. Function of air compressor, okay, and industrial uses of compressed air. We need the industrial uses of compressed air. That means in the industry or in the factories or in the mechanical areas where we are using the compressed air, and what is the function of compressed air, how it is operated, air compressor, how it is operated, and in which concept we are operating the air compressor. Is there any classification of air compressor? Is there in variation in the operations or principle of operations of air compressor? Yes, we will study about that function of air compressor. Okay. And most important is industrial uses of air compressor. When you will study about a machine or a important component of mechanical engineering, you all should know what are the industrial uses, where we can use that compressed air, what is the need of it in our day to day life. So, that is the industrial uses of compressed air, that is most important. We will study about this. Then classify air compressor and principle of operation. Okay. Classification, yes, there are multiple types of air compressor, okay, and we will classify that based on certain parameters, and we will study about all those air compressors, and then principle of operation, in which first classification and then principle, in which principle which compressor is running. Okay. Principle of operation is very important, and from that we will study, will derive the powers and will derive the efficiencies, you will solve the problems that is needed. Okay. Then describe the parts and working principle of reciprocating air compressor. Yes, this is the important part. Reciprocating air compressor in your syllabus, it is included. We will study about working principle of reciprocating air compressor. Okay, gradually I will definitely explain you why we will study about this reciprocating air compressor and why it is widely accepted, and definitely we will study about the parts. Well, what are the various parts, what are the different components of air compressor, we will study about this. Then explain the terminology of reciprocating air compressor. Yes, terminology, what do we mean by terminology? That means which terms we are using this in this air compressor, such as stroke, bore, pressure ratio, free air delivered, and volumetric efficiency, and also there are other terms will be gradually known like piston, cylinder, okay, and valves, and what is the stroke, okay, and free air delivered, that is a new term in this chapter. I will explain about the free air delivered. Then derive the work done of single stage and two stage air compressor. Okay. Single stage and two stage. Coming to the staging of air compressor, why we need stage and what is the application of it, and what is the cost of it, and what is the principle behind the multi-stage compressor. Okay. Definitely I will explain you about the single stage and also the multi-stage compressor with and without clearance. Clearance is also a new word. I will tell you about the clearance. Okay, clearance volume. So, with clearance and without clearance, what happens with clearance and what happens without clearance. And next term is, that is definitely important, solve simple problems. I will teach you and I will tell you about the solving of simple or complicated problems regarding the air compressor. Okay. So, coming to first content, first part, function of air compressor and industrial uses of compressed air. Okay. So, we will move to the next slide, function of compressor, air compressor. Okay. Okay, coming to the definition, an air compressor is a machine which takes in atmospheric air, compresses it with the help of some mechanical energy and delivers it high pressure. It is also called as air pump. Okay. And what do you understand by this definition? How can you define air compressor? Air compressor means we are compressing the air, and you know that is a certain atmospheric pressure of air, that is we are calling that atmospheric pressure. Okay. We are living in the atmospheric pressure, but here what we are doing, we are increasing the pressure of air. Okay. We are utilizing the atmospheric air, we are increasing the pressure of that atmospheric air, and after that we are storing that compressed air, that high pressure air, and we are utilizing further that high compressed air. Okay. And the important term here is pressure. That means we are increasing the pressure of air, and what we are doing, we are using one particular machine that is called as air compressor. In that air compressor, we are absorbing or we are taking the atmospheric air, okay, which takes in atmospheric air, then compresses it with the help of some mechanical energy. What do you understand by this? With the help of some mechanical energy. That means air cannot be compressed automatically, we have to supply some energy, okay, and that with that help of mechanical energy, air is compressed and delivers it at high pressure. Okay. I have told you the important term is pressure. The air is at certain pressure, that is called as atmospheric air, and when the air compressor takes in or sucks the atmospheric air into it inside the cylinder, and after that it compresses it with the help of some mechanical means. Mechanical means some moving parts. That means if we are using the piston, okay, inside the cylinder we are utilizing the piston is reciprocating, and with the help of piston we are compressing the air up to certain pressure. Suppose air is at 1 bar pressure, and our need is to compress the air up to 10 bar, okay, and the pressure ratio obviously is final pressure divided by initial pressure, that is 10 by 1 is equal to 10, and that particular pressure ratio we are compressing the air up to the final pressure, and by using what? By using the mechanical energy. I told you that piston, we are utilizing the piston as the moving part, and with the help of that piston we are compressing the air, that is called as, that means we are utilizing the mechanical energy. And before going to the mechanical energy, where that mechanical energy comes, also piston cannot run automatically. Okay. I will tell you some glimpse about the IC engine. Okay. In the IC engine, what happens? We are supplying the fuel air ratio mixture, fuel air mixture, then the burning of combustion of the fuel occurs inside the cylinder, okay, either by stroke or either by spark or by compression. Then after that power is generated, power is developed, and that power is responsible for the moving of the piston, reciprocating motion of the piston, and after that the reciprocating motion is converted into rotary motion of the crank, okay, and we are freely utilizing that energy, that is the output power. But here what happens, piston will reciprocate and that will compress the air, but to reciprocate the piston we have to provide some energy, okay. And you all know, whenever we are utilizing any type of compressor in your day to day life, you have to provide what? Definitely you have to provide electricity, electrical energy, okay. Suppose the freeze or the AC, at those places we are utilizing the compressor, okay, and we have to supply electrical energy, okay. So here it is air compressor, though it will start the compressor we have to provide what? Electricity. When we will provide the electricity, the electrical energy will be converted into this mechanical energy, and how it will be converted I will tell you later, but the concept is the electrical energy is converted into mechanical energy, okay. And the second point is, an air compressor increases the pressure of air by decreasing its specific volume using mechanical means. This is most important, okay. How the air compressor is increasing the pressure of air, you know, I think you must know or you must aware about the term specific volume. Volume you must know, the air is carrying the some specific volume where when we are putting it inside the cylinder. Suppose this is the cylinder, okay, and that cylinder TDC and BDC, top dead center and bottom dead center, you all know about it, and this volume is, we are calling it stroke volume, okay, stroke volume or swept volume. That means a particular volume of air is taken into this cylinder, okay, and how it is converting the low pressure air into high pressure air. That means we are decreasing its specific volume, okay. Specific volume means volume per unit mass, and we are decreasing thus its specific volume. That means when we are compressing, suppose this is the piston and above the piston this is air, and when the piston is moving upward, okay, it will try to compress the air. When this piston will be moving upward, in upward region air will be there and it will definitely try to compress the air, and when it will compress the air, you can see the volume is gradually decreasing. This is total volume is called as stroke volume, and the volume is gradually decreasing. And what happens when the volume is gradually decreasing? The pressure is increasing. This increases, air compressor increases pressure of air by decreasing its specific volume. You have to keep this in your mind. Later we will utilize it when we will derive the work done, clear, in the PV diagram. So, using the mechanical means. Mechanical means, what do we mean by mechanical means? Here we are using the piston in reciprocating type. In reciprocating type, we are using the piston, that is called as mechanical means, and by using this piston, we are compressing the air, we are decreasing the volume, and we are increasing the pressure. You have to keep it in your mind. Volume, suppose initial volume is V1 and the final volume will be V2, and the volume decreases. Okay. Whenever you will be asked in any interview or anyone, when anyone will ask you about the air compressor, what will happen to volume when the air is compressed, okay? And suddenly you should know and you should answer that the volume will be decreased. Clear? Pressure will increase and volume will be decreased, and our aim is not to decrease the volume, but our aim is to increase the pressure. That is our aim and that is our requirement, okay? And to increase the pressure, the volume is decreased, though we are utilizing or we are using some mechanical means, clear? And next point is, the compressor receives energy input from a prime mover, okay? These are the new terms, you should be acquainted with these terms. From a prime mover. Prime mover means we can call it as a motor, okay? We can call it as a motor. That means the compressor, air compressor receives the energy input from a motor which is attached to the air compressor, and some part of the, very carefully you should listen these points, some part of this energy input is used to overcome the frictional effects, and some part is lost in the form of heat, and the remaining part is used to compress the air up to high pressure. What do you understand by this line, by this most important point? That means here we are using what? A prime mover. Prime mover, I told you that a motor. That means when we are using the air compressor, with the air compressor we are attaching the prime mover, that means the motor. And what is the function of motor? Why we will use this motor and what the motor will do? It is connected with the motor. I told you the piston will not reciprocate automatically. That means the mechanical items or the moving parts will not function automatically. We have to provide some energy, that means there is some energy conversion happens, clear? And where that energy conversion happens and from which energy to which energy is converted, clear? First of all, we are supplying which type of energy? Electrical energy. I told you we are switch on the electricity or switch on the board, and instantly the motor will be started. When the motor will be started, and then air compressor will run, and in which means the energy conversion happens. I am telling you. That means air compression receives energy input from the prime mover. That means when the motor will be started, the shaft of motor is connected with the air compressor, clear? And when the motor will be started and motor will run, that shaft will be automatically running in the air compressor, okay. And that means that is the input energy, okay. The crank shaft will be run, that is the input energy, and we have studied in IC engine that the power available at the engine shaft is called as brake power, okay. And in case of IC engine, that is the output power. But when we are studying about air compressor, the power available at the shaft is called as brake power, but this is the input energy. Clear? In reverse direction, you have to keep it in your mind. When the shaft is rotating and the energy available at the shaft, that is called as brake power, and the brake power is the input energy. Clear? Brake power is the input energy. And after that, what happens when the shaft is rotating and the piston is connected with the shaft through the connecting rod, and the rotary motion is converted into the reciprocating motion of the piston. Clear? Okay. Rotary motion will be through connecting rod. Rotary motion will be converted into reciprocating motion through the connecting rod. And I told you, some part of the energy is used to overcome the frictional effects. Definitely, when the moving part is reciprocating, there is some frictional effects. So, some part of energy is definitely lost to overcome the frictional effects, that is called as frictional power, okay. And that is definitely negative. Clear? And some part is lost in the form of heat, okay, and we cannot stop that. Heat is power is energy conversion happens, heat will be generated, moving part is running. So, that heat will be lost to the atmosphere in the form of that energy is lost to the atmosphere in the form of heat, okay, dissipated to the atmosphere. So, suppose brake power is the input power, okay, and I told you what is lost. Lost part is frictional power, and frictional power is the lost power, and the remaining power which is available, that is responsible for the moving of piston inside the cylinder, okay. That is responsible to compress the air, that energy is responsible to compress the air. That means what is the remaining energy? That remaining energy we are calling that indicated power, okay. That remaining energy we are calling what? That is called as indicated power. That means this is the output, In case of air compressor, this indicated power is the output power, and brake power is the input energy. Clear? Okay. This brake power, which is the power which is available at the engine shaft, that is input energy, and the frictional power which is lost due to the frictional effects, that should be what? Subtracted from the input energy, and the remaining energy which is available, that is responsible to compress the air, that is called as indicated power, okay. Clear? And whenever we will calculate the efficiency term, mechanical efficiency. If I will tell you about the mechanical efficiency, later on I will discuss about various efficiencies, but if I will tell you about mechanical efficiency, the formula is output divided by input. And what is output? Mechanical efficiency is equal to output is what? Indicated power divided by input is brake power. Clear? And you have studied in IC engine, the mechanical efficiency is brake power divided by indicated power, because at that place brake power is the output and indicated power is the input. But in case of air compressor, brake power is the input. Why brake power is input? I told you, because we are supplying the electricity, we are providing the energy, and that energy is responsible for the running of the shaft, and that is called as input energy. We are providing that input energy, and after that, and that brake power is the input energy, and after that the piston is reciprocating, that is the output, and that is called as indicated power, and in middle the some part is lost due to the friction, and that should be subtracted from the input energy. So, that is why in brake power minus frictional power, that is equal to indicated power. Clear? This equation you have to remember, very important, and mechanical efficiency, that is indicated power divided by brake power. Clear? So, this much we will discuss about the industrial uses of compressed air in the next slide. Industrial uses of compressed air. Definitely we should know, we all should know what is the uses of compressed air and why we will study about this air compressor. Okay, where we can use this compressed air. There are various applications of compressed air in our society or in our industries, in our day to day life, in our house. Okay, and I am telling you some applications. Okay, you have to remember all these applications of what compressed air, industrial uses of compressed air. This is most important question in your syllabus. What are the industrial uses of compressed air, and you can elaborate these terms. Okay. First is spray paintings, then air tools, okay. Then vehicle propulsion, then railway braking system. Railway braking system we are utilizing the compressed air. Then underwater diving we are utilizing the compressed air. Refrigeration using a vortex tube, okay. Air starting system, okay. Then cleaning dust, okay. Then injection molding, we are also utilizing the compressed air. Then abrasive blasting, also we are utilizing the compressed air. Apart from this, also there are various applications in your textbooks. You can refer your textbook. It will be definitely helpful for you, where we can utilize the compressed air. Okay. So, next coming to the classification, I am telling you how can you classify the air compressor. And okay, classification of air compressor. So, this is the initial starting classification. Okay. First is air compressor is broadly classified into positive displacement type and dynamic compressor type. Okay. Positive displacement type and dynamic compressor type. Then again it is classified into rotary compressor and reciprocating compressor. This is important. Positive displacement type compressor is again classified into two types, that is called as rotary compressor and reciprocating compressor. I was telling you about the reciprocating compressor, about the piston. I was telling you about the cylinder piston, that is under the reciprocating compressor. So, it is under positive displacement type, and this is the compressor classification. Okay. Though it is widely used, that is why I was telling about the reciprocating compressor. So, coming to the dynamic, again dynamic compressors are again further classified into two types, that is centrifugal type and axial type compressor. And here rotary type air compressor is again classified into screw type, lobe type, liquid ring, scroll, vane. These are different types of compressor under the rotary type. And under the reciprocating type, that is single acting, double acting and diaphragm, and basically mainly it is classified into single acting and double acting. Definitely I will tell you what is single acting and what is double acting. And under the dynamic type compressor, that is centrifugal and axial, and this much classification we will study, but in broadly broadly we will discuss about the rotary and reciprocating type compressor. That means we will broadly know about the positive displacement type air compressor. Though it is this reciprocating type is widely accepted in the industries, that is why we will discuss about positive displacement type and we will know about the functions of dynamic compressors. Okay. And under the reciprocating, double acting and single acting, though it is important, single acting and double acting will I will tell you about the single acting reciprocating air compressor and double acting reciprocating air compressor, because this is needed while you will solve the problems. In your problems there will be mentioned in a double acting reciprocating air compressor, and at that time which value you will take, and if in the question it will be given like single acting air compressor, at that time what value you will take. This is important. So, we will discuss about this positive displacement, then dynamic, then rotary, then reciprocating, and then double acting and single acting. This is important, that is why we will study about this. Okay. Then coming to the next slide. Okay. So, positive displacement type, coming to the positive displacement type. Okay. In this type of air compressor, it is a compressor which uses the reciprocating component such as plunger, diaphragm or vanes or for air compression. Okay. I am telling you why it is called as positive displacement type and what are the further classification of this type of positive displacement type of air compressor. This compressor works at constant flow rate, and further it is known as positive displacement compressor because it compresses the air by displacing the volume of compression cylinder. Okay, this is important. Why it is called as positive displacement type? Because it is it compresses the air by displacing the volume of the compressor cylinder. Before that, before we will study about the positive displacement type, I am telling you about some terms. In the positive displacement type, we will know about one cylinder and piston and cylinder head will be there, and inlet valve is there and outlet valve will be there. Okay. And inside the cylinder some clearance volume will be there, and TDC, that is top dead center and bottom dead center, and in the volume in between the top dead center and the bottom dead center, that is called as stroke volume. Though piston is moving in between the TDC and BDC. Okay. TDC and BDC term, you all know about this. TDC and BDC, though the piston is moving in between the BDC and TDC, that is why that volume is called as stroke volume, or we can call it as swept volume, SWEPT, swept volume. So, coming to the piston is reciprocating inside the cylinder from the BDC to TDC, and above that some clearance volume is there, clearance is provided. Further I will tell you why clearance is provided and what is the need of it. Okay. And what happens in this positive displacement type, what happens? It compresses the air by displacing the volume of compressor cylinder. Okay. What happens? It compresses the air by displacing the volume of compressor cylinder. That means this cylinder is carrying some volume. Okay. We are displacing the volume of the cylinder by using some compression means. That means by using the piston we are displacing the volume of what? Of the cylinder, and after that it is compressing the air. which is present inside the cylinder. That is why that is called as positive displacement type, and it compresses the air at a constant flow rate. Okay. This term also you should know and you should remember. This positive displacement type of compressor works at a constant flow rate, and it compresses the air by displacing the volume of compressor cylinder. That is why that is called as positive displacement type, and these type of compressors are widely used in various industries. I told you this type of compressors have various uses, various applications in our industrial sector, in our societies, and particularly reciprocating type of compressor is used widely in our societies, in our industries. So, coming to the dynamic compressor. So, dynamic compressors working principle is based on thermodynamic principle. Air introduces through the inlet of the compressor into the chamber. Okay. I was telling you about the valves, that is inlet valve and outlet valve. Certainly, there are two entries, not entries, that one is entry and another is exit. One is inlet valve and another is outlet valve. Through the inlet valve, air is entering into the cylinder, and after that it is compressed inside the cylinder, and after the compression it will exit the cylinder through the outlet valve. That means, when it is entering into the cylinder, the fresh atmospheric air is entering into the cylinder after the filtration process, and inside the cylinder what happens? It is compressed up to the certain pressure, up to our required pressure, up to our desired pressure. Okay. That means, the low pressure air is converted into high pressure, and after that when it will be, the pressure will be increased, that high pressure air will leave the cylinder through the outlet valve. That outlet valve will be opened automatically, and the highly compressed air will leave the cylinder through the outlet valve, and after that it will be stored inside in the storage tank. Okay. In the storage tank, the compressed air will be stored. Clear? So, in the dynamic compressors, what happens? The air introduces through the inlet of the compressor into the chamber. The chamber is there, and through that through the inlet air is introduced. That means, it takes in the atmospheric air into the chamber through the inlet. Clear? And when the air passes between the blades of the impeller, when the air passes between the blades of the impeller blades provide kinetic energy to the air. Okay. And it is the function of dynamic compressor. The impeller is there, when the air will be taken into the cylinder, and it will be passed through the impeller blades, and that blade will provide kinetic energy. And you all know kinetic energy related with what? Kinetic energy is related with velocity. Clear? Kinetic energy is related with velocity. That means, these blades are providing the kinetic energy to the air. And after that what happens? When diffuser is connected with the compressor, the diffuser converts the velocity of the air into pressure. Okay. And after that, air discharges through the outlet of the reciprocating compressor. That means, what happens here? The velocity, that means, I told you it increases the kinetic energy of the air. That means, velocity increases, and when the velocity increases, the diffuser converts the velocity of the air into the pressure. Okay. And when the velocity is converted into pressure, kinetic energy is converted into pressure energy, and at that time the pressure of the air increases. That means, low pressure air is converted into high pressure air, and after that it will be discharged through the outlet of the compressor. Okay. It will be discharged through the outlet of the compressor. Clear? Coming to the next slide, what happens? Coming to the reciprocating compressor. Clear? Reciprocating compressor is used to produce high pressure gas. Okay. Why we are utilizing the reciprocating compressor? Reciprocating compressor normally is used to produce the high pressure gas. Whenever we need very high pressure gas or high pressure air, we are utilizing this reciprocating type of air compressor. That is why it is highly or widely used. Clear? Why I was telling the reciprocating compressor is widely used in our industrial sectors or in our societies. The reason behind it can be used to produce the high pressure gas or high pressure air. Clear? And it uses or utilizes the displacement of piston in the cylinder. Clear? What it utilizes? It uses the displacement of the piston in the cylinder. I was telling you, it's the inside the cylinder, the piston is there, and this reciprocating type of air compressor uses this piston. Okay, piston is displaced along the cylinder. This is TDC and BDC. Piston is reciprocated along the inside the cylinder from the BDC and to TDC, and this displacement of the piston is responsible for the compression of the air inside the cylinder. Clear? So, it uses the displacement of piston in the cylinder for compression. It handles, this is important, it handles low mass of gas and high pressure ratio. Okay? Low mass of gas and high pressure ratio. That means, one point is that it can be converted, it can convert the pressure of the pressure of air to the high pressure. That means, it can convert the air pressure up to high pressure. Okay? And I was telling you about the pressure ratio. It can handle the high pressure ratio. Before going to the pressure ratio, I am telling you, suppose the inlet pressure is P1. Okay, inlet pressure is P1. That means the air takes in the the compressor takes in the atmospheric air into the cylinder at pressure P1. That pressure P1 is the inlet pressure, that is atmospheric pressure. What is it? This is atmospheric pressure. And another one is outlet pressure. Okay? And what is that outlet pressure? Outlet pressure is the required pressure. What is the required pressure? That means, suppose we need to compress the air up to 8 bar. Okay? And that means that 8 bar is our required pressure, but initially the air was at atmospheric pressure, that is at 1 bar. Clear? And when we are I am telling you about the pressure ratio, that pressure ratio is the ratio between outlet pressure and inlet pressure. Outlet pressure and inlet pressure. And here the outlet pressure is P2 and the inlet pressure is P1. Outlet pressure is our required pressure. In the example I was telling you, the outlet pressure we need suppose 8 bar, and the inlet pressure, that is we need 1 bar, and the pressure ratio, here the pressure ratio is 8. Clear? Suppose in the question, in your problem, the question data will be given like the pressure ratio is 8. Okay. So, you can clearly understand that the ratio between the outlet pressure and the inlet pressure is 8. That means, when I was telling you that reciprocating type of air compressor can handle high pressure ratio, that means suppose it can handle up to suppose 20 bar. Clear? It can handle up to pressure ratio of 20. Pressure ratio of 20. That means, suppose outlet pressure divided by inlet pressure that is equal to 20. If the inlet pressure is at atmospheric air, exactly at atmospheric air, that is 1 bar, that means outlet pressure is 20 bar. That means we can convert the pressure of air of 220 bar by utilizing this reciprocating type of air compressor. This is the meaning of it. It can handle high pressure ratio, means it can convert the low pressure air of to certain high pressure. That is the speciality of this type of reciprocating type of air compressor. Though further we can use the multi-staging. In a single stage we cannot convert the pressure up to certain limit, up to high pressure. So, that is why we are using the multi-staging, double stage multi-staging air compressor. So, but it can convert the pressure up to high pressure, that means it can handle the high pressure ratio. And coming to the rotary compressor, rotary compressors are used for low and medium pressure ratio. Okay. That means rotary compressors cannot be used when we will talk about high pressure ratio. In the industrial sectors, where we are utilizing the high pressure compressed air, at those places we cannot utilizing this rotary type of air compressor, because these compressors are particularly used for low and medium pressure. Okay. If the pressure ratio is certainly less or medium type, at that time we can utilize this rotary type of air compressor. They usually consist of a blade wheel or impeller that spins inside a circular housing. They handle a large mass of gas. Clear? This is the difference between the reciprocating and rotary type air compressor. What is the difference? In the reciprocating type, I was telling you that it can handle the low mass of gas. At a time, it cannot handle the high mass of air. Okay? It can handle low mass of air, but the pressure ratio is high. Clear? But in case of rotary type, it can handle large mass of gas at a time, but it cannot handle high pressure ratio. Okay. For medium or low pressure ratio, we can utilize the rotary type of air compressor. Then coming to the fourth point, reciprocating compressors are again classified into single acting and double acting. Okay, according to the need of pressure ratio. Okay. So, single acting, what is the single acting and what is the double acting type of air compressor? I was telling you in this flow chart, the reciprocating type further classified into single acting and double acting. Single acting and double acting means, if the cylinder, inside the cylinder, piston is reciprocating, this is the piston and this is the cylinder. If at the both side of the piston, here the inlet will be there, at the both side of the piston, if the inlet will be there, then it is called as double acting. Okay. That means when the piston is moving upward, it is compressed the air of the upward portion, and again when the piston is moving downward, it will compress the air of the downward portion. This is the inlet, this is the outlet, this is the inlet and this is the outlet. Clear? This is called as double acting. That means it is it has more efficiency. Okay. And at a certain time it can compress more amount of air. Okay. This is called as double acting. And in case of single acting air compressor, what single acting is doing, simply if at one side of the piston the air is entering and the leaving, then that is called as only single acting. That means if at one side of the piston, this is the piston, if at only one side of the piston the inlet is there and the outlet is there, then that is called as single acting. and if at the both side of the piston the inlet and outlet is there, then that is called as double acting air compressor. Okay. And dynamic compressors are further classified into centrifugal type and the axial type air compressor. This is all about your classification of air compressor.